easy because we've done all of this before. We just got a new function. That's all. Remember last semester I told you guys that we're going to be applying transformations to all kinds of. Okay, Algebra 2 Part 1. In your Algebra 2 Part 1 course, uh, hey, guys, quiet down. You're going to do transformations and you're going to apply it to all different functions. And that's what we're doing here. We got new functions. We got exponential growth and decay. Actually, so the general function form, and we're going to expand on this later, is a times b to the x. I don't know. Most of you probably had this in Algebra 1. You can't see what? Okay, so if I have exponential growth, and I know a lot of these graphs, well, not a lot, but some of these graphs, it's going to be hard to see the x and the y axis. I always like to highlight them. So here's my graph that they give me. And it's fairly obvious that this is growth. And then my decay graph, decay model here. Is it starts, it's a decreasing graph here, and it tries to touch this line, the x-axis, but doesn't hit it. Okay, so one's growth and one's decay. So we're going to do this now. We just did analyzing graphs whatchamacallit, last Wednesday, right? Because you guys had like 3 months off, right? Okay, so last Wednesday we did analyzing graphs. Well, that's what we're going to apply to the growth and decay graphs. Okay. So what we're going to do, here's my function. I'm going to put my function into my y equals button. There's my function. And again, I'm going to use the second line here because I like the red graph. And I know there's a way to change the colors in your calculator. I just don't feel like spending time. Well, the f of x is y equals. Okay, that's your y equals button. Okay. So I'm going to put in 2 raised to the x. Now you guys, you got a little bit different. You got updated software. You might have to hit the arrow key to get out of your exponents. Hit graph, and it's obvious what kind of graph do I have? Growth and decay. Growth, right? All right, so I'm going to get some points so I can graph this thing. I'm going to go to my table, second graph. Let's get some points here. Yeah, I'm going to start at -2. I got -2 for my x and 0.25 for my y. So -2 and 0.25, which is a quarter. So right about there. Then I got -1.5, which is a half. So -1.5. Then I have 0.1. What's special about this point? 0.1. My x value is 0. Y-intercept. Awesome. Y-intercept, my x equals 0, where it crosses my y-axis. Okay, what else do I have? 1, comma 2. And I'm going to put maybe 2 more because I want a pretty accurate graph. 2, comma 4. And I'm going to go one more. 3, comma 8. Now, if you're a good grapher, you don't need all of these points. But I'm kind of a bad artist here. So again, I'm going to look at my graph and go ahead and graph this. Looks like it hugs my x-axis here, but then starts exponentially growing here, hence the name. So there's my graph. All right, so let's analyze this. We already said what the y-intercept is, right? 1. My domain, my x values. Awesome. Okay. My smallest x is negative infinity. My largest x is positive infinity. What's my range? Ooh, 0 and infinity. Infinity is easy, right? Because it keeps going up here forever and ever. The 0 is not so easy to tell. Remember, it's trying to, and let's talk about this for a minute. It's trying to cross this line, right? The x-axis. What's the equation for the x-axis? Y equals 0, right? Horizontal line at 0. It's trying to get to that 0, and I can even see it on my calculator on my table. See how my y is trying to get to 0? It's getting smaller and smaller and smaller, but it never ever reaches. In fact, it's getting so small your calculator has to put it in scientific notation. It never touches that 0 value though. So we call this line where the graph comes down and tries to reach 0 the horizontal asymptote. That's that y equals 0 equation. Now, because it never reaches 0, tries to get to 0 for the range, right? We're going to say, hey, we'll just put a parenthesis there so it doesn't include 0. Now, do you guys remember the end behavior? Yep, the f of x approaches blank as x approaches negative infinity or goes to the left. And then the f of x approaches blank as yeah, it would be easier just to put it down instead of trying to do your own creation. As x goes to the right or positive infinity. So let's see. As x goes to the left, there's my x. It's going to the left. Where's my y going here? It's trying to get to 0. Okay. As my x goes to the right, where's my y going?
Positive.
Good. And then we go. We just analyzed our growth function. Yes, ma'am.
Will the end behavior be the same as the range, like each time?
It'll be one of the numbers. Okay. If this was a negative sign, if this was a negative 2x, it wouldn't be the lowest number, it'd be the highest number. Okay. So yes, it's going to be a part of the range somewhere. Good question. Okay, let's do the next one. If we did growth, what do you think this is going to be? Yeah. Okay, so always put fractions in parentheses. 1 divided by 3 raised to the x. Graph it. And there it is. Decay. Okay, let's get some numbers so we can graph it. Some ordered pairs. Second graph. Let's see. Oh, here's a good one. -2, 9, -1, 3, 0, 1. Here's our y-intercept again, right? What else we got? Yeah, 1 comma point 3. And then I'm going to put the next one on there, 2 comma point 1. That's about all I'm going to be able to get on this graph. -2, 9. -1, 3. 0, 1's our y-intercept. 1 and 1/3. 2 and point 1. So it's going to try to get to that x-axis, right? But never touches or crosses it. Okay, our y-intercept again is 1. Domain, in fact, for our growth and decay models or graphs for this class, your domain's always going to be negative infinity, positive infinity.
Same thing can be said for growth or not.
For the what?
For growth.
Yes. Range, well, again, we got that horizontal asymptote here. That line that it reaches, tries to reach but never touches or crosses, happens to be our x-axis. 0. No. And we're going to look at that in 2 problems. Okay, my highest y value, infinity. And behavior, the f of x approaches blank as x goes to the left or negative infinity. The f of x approaches blank as it goes to the right or positive infinity. Okay, as x goes to the left, so we're looking at the end here, my y, good. As my x goes to the right, again, it's trying to reach that 0. Okay. Okay, before we turn the page, do you guys notice the difference between growth and decay? Ah, fantastic. This number actually has to be, that's our B, has to be greater than 1. Okay. You can't see it? Can you see it now? Okay, so my B here, right, that's my B. Then my B has to be greater than 1.
The P for decay has to be less than.
Yes, not only does it have to be less than 1, but it has to be greater than 0. So what does this tell us? Fraction between 0 and 1. Okay, like 1/2, 3/4, 2/5. But be careful if I have a fraction there like 8/7, that's greater than 1. Even though it's a fraction, it's greater than 1. It's a growth. Also, something else that I guarantee will be on the SATs. They will have a fraction like this. In fact, turn the page. I think it's the next problem. And they have a negative x. What does that do to our fraction? Having a negative exponent?
Takes it away.
Not take it away. Yeah, it makes it a reciprocal, right? So this is actually another way of writing this is the f of x equals 4 thirds raised to the x, right? Because we're flipping that, make it positive.
If the negatives wait, because we have to flip it to positive.
It's going to reflect it. You're right. What?
Oh, so we have to turn it into a positive. So
You don't have to. We're going to put it in our calculators as this. But what I'm saying is a lot of students, because this is, again, another quiz or test question, they'll say, hey, is this growth or decay? And that's the question. You look at it and you see that your B is, well, it's a fraction between 0 and 1. So it must be decay. And it'll be wrong because it's to the negative exponent. You have to flip it. It's greater than 1, so it's growth. So be very careful on those SAT questions. All right, so we're going to go ahead and put this one in there. Okay, we're going to put the negative exponent just to show you that it's going to come out growth. So I have 3/4 raised. Now I got to use the negative key on this, right? Negative x. And I'm going to graph it and see how I get a growth and not a decay because of that negative exponent. I even think it's on our quiz. That whole is this growth or decay thing. All right, let's get some points. And Asher, I'm going to get to that, what you said before, if there's a negative sign out in front. Let's get some points. How about no, they got negative? They're starting at -1. They put in some x's here. 0.75 or 3/4. 0, 1. So there's our y-intercept again because my x is 0, right? Y-intercept. 1 comma 1 and 1/3 or 1.3. 2 and 1 and 2/3. Well, let's see if we can graph these points. -1 and 3/4. -1 and 3/4. My y-intercept, 1. 1 and 1/3. So this is very slow here. 2 and 1 and 3 or 2/3. I'm going to see if there's another point here. 4 and 3 looks pretty good. 3.1. Just something I can make somewhat of a accurate graph.
wait, I forgot to do-
That's okay. I'm just trying to get an idea of the graph. Y-intercept, I already said it was 1. Domain is going to be, yep. Range and or asymptote. I like to do the asymptote first because that's going to be part of my range. Again, it's our x-axis that it's trying to reach and cross, but it never does. And the equation for that is y equals 0. Which means it's going to be the smallest number for our range. And this goes up to infinity. And the end behavior. as x goes to the left, the f of x approaches blank as x goes to the right. Okay. Let's see. As x goes to the left, again, my y is trying to get to that 0, right? And as my x goes to the right, my y is going towards infinity. All right. Here's the expanded form. Okay. And you guys remember seeing this before in the past, right? With absolute value function, vertex form. We did this with a number of different functions. And I told you guys back in semester 1 or algebra 2, part 1, right, Keith? That you're going to see these transformations throughout the course. Well, if, and I talked about mathematical symbols, so if I have my h inside the mathematical symbol, which way do I go? Left or right, and it's opposite the sign. Okay, my k, which is outside the mathematical symbol, which way does that go? Up or down, and same sign, right? Follow the sign. Now, the A, that A does a couple of things, right? And as Asher was saying, if my A is negative, it reflects. It makes that whole graph reflect about, I believe it's the horizontal asymptote. I can't remember. But it reflects.
Whatever A is, though, right?
Yeah.
So
If it's a
A is
negative,
gonna-
now if it's a negative, it just takes, like this growth, would flip it.
And if the base value of A is 2, then you're reflecting on 2.
Yeah.
Y on 2.
Okay, so, and the A does another thing, right? Remember? I told you guys, think of it as the slope, but it really isn't, it's not a constant slope, so I can't really say it's a slope because it changes. It's more or less the steepness of the line, but I like slope because it makes you think that it's the slope changing. Okay, here's our problem. So that's the transformations we're going to see, right? Here's our function. So they want us to put this and graph it. Going to put this in my y equals. So I have 2 raised. Now you're going to have to put the exponent in parentheses, okay? The x minus 1. X, oh, parentheses, x minus 1. Close that parenthesis. Oh, shoot. Close that parentheses. Now your calculator, you have to hit that right arrow key to get out of your exponent. Then hit your minus 4. Graph it. And there's our graph. It's definitely growth because b is 2. It's greater than 1. So let's get some points here and make a sketch of our graph. Let's see. -1 and -3 3/4. 0, -3.5. 1, -3. 2, -2, and 3, 0. Okay, so let's go ahead and make our graph.
Wait, I'm confused. Uh,
Are you good?
yeah,
I'm just plotting points.
yeah, the numbering of the points just got to me.
Yeah, I mean, it's kind of hard because a lot of them are decimals.
Confused my simple brain.
So if I look at this, my graph here is trying to get to this horizontal. Here's my horizontal asymptote, right? It's trying to get to -4. So there's my horizontal asymptote at y equal -4. Okay, so y equal -4. Um, if I look at my equation here, here's my -4, right? It's my k. So my horizontal asymptote is y equal k. Okay, the domain is easy, right? Negative infinity, positive infinity. My range is, well, it's going to positive infinity. So the -4 goes in front. A lot of this stuff we can get even without the graph, which is the next problem. Transformations. Well, looking inside my exponent here, my h, not a left. Yep, it's opposite the sign. And then my k is
Down.
down 4. Good.
Oh, I thought the growth reference. I thought growth was the transformation. Guess what?
We're looking at our h and k, our a, h, and k for transformations.
Right. Sorry. We also do stretching by 2.
Yes. Okay, so let's look at this one without even graphing it. Okay, my transformations. Well, I don't have any because I'm subtracting 0 and adding 0. So there's no transformations, right? Domain. That's easy because they're all negative infinity, positive infinity. Our range. I'm going to do the horizontal asymptote first. It's y equals k, right? So y equals 0. We know it's growth, so it's going to positive infinity. And then my smallest number, or my range, is my horizontal asymptote.
Presume it's growth because it's not negative.
Because my b is greater than 1.
Got it.
Okay,
Sorry.
that's quite all right. Okay, let's list the transformations in this one. Here's my h. So it's going to be left 4 and then down 7. Domain, easy. No matter growth or decay, it's. And then I'm going to, like I said, I'm going to do my horizontal asymptote first. Y equal k, which is -7. So my -7 is going to be in my range. It's growth, so it's going to go to positive infinity. And there's my range. Okay, questions?